Hello everyone, and today we are going to start chapter 9. Chapter 9 is about shell and tube heat exchanger. So we have already seen the chapter 8, which was about double pipe heat exchanger. So now we will move to the analysis and design of shell and tube heat exchanger. So the shell and tube heat exchangers mainly consist of a big shell and a number of tubes. The tubes are consist and they are accommodated in a big shell. So the shell is a large vessel and there are a number of tubes uh, fitted in it. So as you can see that this is the bundle of tube here and this is fitted inside the big shell. This is shell. And here again if you see that this is a big shell and then there are many tubes inside the shell. And so that's why it is called shell and tube heat exchangers. And there are partition like the plate, as you can see this plate here, and the tubes are passing through this plate. So this plate called baffle, and we will discuss this later in this chapter, that how there are baffle designs. So as you can see that how the flow moves from shell side and from tube side. So here we see that the shell fluid is going into the shell from this uh, uh, shell fluid is going from this port into the shell, and then it is moving in the shell, so it is going here and then moving across the tube like this. It is moving across the tube like this and finally it is coming out. Whereas in the case of the tube fluid is going in from here and then going in the tube, and from here coming back through the tubes, and then it is going out here. So this is how the flow takes place in shell and tube heat exchanger. So it depends upon that how many rounds of the fluid you want to make inside the shell. So we will discuss that. So this is the cut section of the shell and tube heat exchanger. So as you can see here that the shell fluid is entering from here and then it is moving in a spiral manner and then it is coming out. So we will discuss this, that why the design is like that. Whereas for the tube fluid, all the fluid is going into the shell from here and then the tubes are carrying the fluid here and then the fluid is going out from here. So what is happening that there are number of tubes and there is a tube sheet here which holds the tubes and there is another sheet here which holds the tube, and there are plate supports in the middle of the heat exchanger. So these plates act for two functions. They support the tubes as well as they guide the shell flow. So the fluid in the shell is coming here and there is a plate, so the fluid cannot move like this. So the shell fluid is going in the passage and then going up and then going down and then going up and then going down like that, and then it is moving in a spiral manner. So the outer body is called shell and then there are two tubes inside. Okay. So when all the fluid in the tubes and that all the tubes are carrying fluid from one end to another end, then this type of heat exchanger we call it one pass heat exchanger, as written here, one pass, that there is only one time interaction between the shell fluid and tube fluid and they are passing each other only once, so that is why we call it one pass shell and tube heat exchanger. Then further we have the two pass shell and tube heat exchanger. So as for the shell fluid, it is same, there is no change. Then the shell fluid is entering from here and then it is moving in a spiral manner and then going out. Whereas for the tube fluid, which is entering from this inlet plenum, this is called the tube site inlet plenum, and this is the manifold here, and this is the outlet plenum. So the tube side, the fluid is entering here and half of the tubes are carrying the fluid to the other side, and from the other end the rest half of the tubes are bringing the fluid from the shell and tube heat exchanger. So basically the fluid is getting two times to interact with the shell fluid. So that is why it is called two pass. Whereas the shell fluid is just moving on a single path, no repetition. But for the tube fluid, it is going along the length of the heat exchanger, and then it is coming back. So this is called two-pass shell and tube heat exchanger. So the two-pass shell and tube heat exchanger that can be designed in a way that all the tubes are bent. There is a bend in the tube. So the tubes are bended. The fluid in the tube is going from the inlet, and then the band tubes this bringing back the fluid here. Whereas for the shell fluid, the fluid enters here and then spirals inside the shell space and then goes out. The other thing remains the same, that there are baffles. This plate we call it baffle. This plate we call it baffle. There are baffles, and there is a shell, and there is inlet and outlet ports, inlet and outlet plenums. So what is the material for the shell and tube heat exchanger? So if we talk about the tube material, then the inner tubes requires an effective combination of durability and corrosion resistance and thermal conductivity. The regular materials used in their constructions are copper, stainless steel, copper and nickel alloy. So basically these are the materials which are mainly used for tube fabrication. The other metals are used in device fitting and bonnets and heads. The tube can be drawn tubing, and it can be seamless and or belted. Extruded tubes with fins and interior rifflings are sometimes specified for certain heat exchange transfer application. And often the surface enhancements are added to increase the available surface. Surface enhancement means that putting the fins or some other manners so that the surface area of the tubes are enhanced, that we call the surface enhancement. So the fin tubes are also recommended sometimes when you want to increase the heat transfer coefficient. For the baffles are usually stamped, punched or machined and drills, and such configurations are vary based on the size and application. The material selection must be compatible with the shell side and to avoid the failure or as a result of corrosion. So the material should be compatible with the shell material, otherwise there will be a formation of anode and cathode, and there may be a possibility of corrosion in it. So the shell side, a variety of materials are used in the design of shell and tube heat exchanger. So the material include the carbon steel, stainless steel, copper, bronze, brass, titanium, and various alloys. Generally, the outer shell is made up of durable and high strength metal such as carbon steel or stainless steel. Now, what are the advantages of shell and tube heat exchangers? So, if we see the advantages, that it is ideal for large scale application, and it has a relatively large surface area to volume ratio, and it can withstand the mechanical stresses during the construction, shipping and installation, etc., and even on operation. It is commonly used in petrochemical industries where dangerous substances are present. The compact design, so it's a compact design than the double pipe heat exchanger, because in a big shell you can put a number of tubes, and that basically enhance the surface area to large extent. So if we see from the surface area to volume point of view, the shell and tube heat exchangers give us a big advantage, because the surface area to heat transfer can be much higher than the double pipe heat exchangers, and the cost occur for the for design the process is much lower than the double pipe heat exchanger. But at the same time, there are some disadvantages. So what are those? That it's very heavy and bulky, and the baffles are usually cause mixing in the fluid, and once the shell and tube heat exchanger is installed, so you cannot you cannot customize it anymore, and it is inflexible, and sometimes due to the presence of baffles inside, it is subject to the water hammer and corrosion, and there are high pressure losses on the shell side because the shell side fluid flow in a spiral manner, and it occupies large space, so its footprint is very large. Now come to the baffles. So how do we design the baffles? So baffles are the plates which are put in between the two ends of the shell and tube heat exchanger, and it is put over the length. So it facilitates the fluid to spiral around and move from lower to upper part of the heat exchanger. So there are different configurations of baffles, and you see, as you see here, like segmental type, segmental and strip type, disc and donut type, and orifice type. So the tubes can be placed inside the shell in a different manner. So it can be placed in a triangular manner, or it can be placed in a square or a square or rhombus manner, like a square with at an angle of 45 degree and a square at an angle of 90 degree. Similarly, the triangle at an angle of 30 degree and at an angle of 60 degree. So when we find the area for the heat transfer, then the total area for the heat transfer becomes number of tubes multiplied by pi d L. And the number of tubes depends upon the shell diameter. So, here you need to notice that the tube pitch, which is center to center distance of the two tubes, it can vary from 1.5 to 1.25 to 1.5 time typically. So it's a pitch ratio, that is the diameter over pitch can be pitch over diameter can be 1.25 to 1.5 typically. So the pitch can be 1.25 to 1.5 times of diameter.